Okay, so today this particular experiment that I've got set up for you is an opportunity for you to come and observe some of the common elements that we use in class. And you can see that I have put some common elements here on the sheet. I'm just going to talk a little bit to you about what the similarities that exist between some elements. And then I'll move on and give you some examples of compounds, and I will talk about the halogens, which are quite an important group of gases that you'll be looking at. So you can see up here, this yellow substance that I've got here on this watch glass is sulfur, and it's a yellow substance, and you can see if I touch it, it's rather brittle. Okay, you would find that on the right hand side of your periodic table, so you might want to check that out. And you can see obviously that it's brittle, it's coloured, and it's in a powdered form. Okay, so moving down, you can see this is a piece of iron. We all know what iron is. You can see that it has been beaten flat. Okay, we say that in chemistry that it is malleable. It is also ductile, which means it can be rolled into a wire. And you can see that there is also a little bit of oxidation going on, which means that some rust has formed on the outside. Okay, so moving right along, this silvery substance that's been that's in I guess little balls is zinc. It's metallic. Again, if I was to get a hammer, I'd be able to beat that flat. It would be malleable. And moving down here, I have lead. Okay, so you can kind of see that these ones down here on the left hand side of the periodic table, and you can see that they've all got something in common as I point to them. So this one here I'm just going to talk about this one. This is magnesium. Magnesium we use a lot because it has a really nice reaction with oxygen and it forms magnesium oxide. If you actually scan in closely, you can see that there's also a little bit of oxidation going on the outside of this as well. Okay, so magnesium is of course a metal. Now I've actually grabbed silicon and carbon out because when you look at silicon, it almost resembles a metal. It's shiny and it's silvery, but if you look at it closely, you can see that it's kind of brittle and it almost shatters. Okay, so that's kind of telling me that it's kind of similar to a metal, but it kind of isn't. And if you actually look to see where it is on the periodic table, you will see that it's close to something called the staircase. Okay, so you can actually research about what the staircase is in the periodic table and look at some characteristics and similarities of elements found in that particular area. And here is another one. This is carbon. Again, it's kind of in a different position. It sort of looks metallic, but it's kind of not, because if I was to get a piece of this and if I was to snap it in half, you would see that it actually would break. Okay, so it doesn't appear to be as strong as some of the metals that we looked at on this side, and if I got a hammer, I could probably smash it as well and it would crumble. Okay, so those are just some a few basic elements. And just moving down here, my last one here that I wanted to talk about is copper, and you can see we should all probably know what copper is. It's metallic, and obviously we know that we can roll that into a wire and that it's malleable. Okay, so there are some basic metals and non-metals. You might want to think about some of the similarities that you observe with them. Now, one thing I wanted to really talk about for this lesson is you can see down here I have what we call gas cylinders here, and if you look on group 17, right on the right hand side of your periodic table, there is a really important group of gases called the halogens. Okay, and they have the symbols fluorine, chlorine, bromine and iodine, and they're super useful obviously with forming compounds because they're basically highly reactive. Okay, so you can see that fluorine has a characteristic colour of being a pale yellow, chlorine pale green, bromine kind of a brownish orangish yellow colour, and then this final one, iodine, you can see that as we move down this particular groups, fluorine's obviously the most reactive and then it becomes less reactive, that this is fluorine is very gaseous, but as we move down, bromine's actually a bit of a liquid here in the bottom. The iodine forms more of a solid, okay? So you can see that we've got a sample of iodine that's sitting here in the bottom, and what we actually did is we put some warm water in here just so it would speed up the reaction a bit and allow that that gas to be diffused. And the concept with this particular substance, so I've always said that iodine is one of my favourite elements from the periodic table, is that it has the ability to sublime into a gas because the molecular forces between this molecular substance are very weak, and you can see the characteristic colour of this gas is a nice purple colour. Okay, so those are some just elements that we've talked about, and I'm now going to move on to looking at a little bit about some of the compounds here. And you can see that this particular one up here, I put it on black cards so you can see it, is sodium iodide. Now it's really interesting because I've got some sodium in the fume hood which I'll bring up later, and we can actually look at the characteristics of sodium iodide. But the from memory, hopefully if you can recall from previous years, the ion for sodium is Na+, okay, and the ion for iodide is I-, okay. So one thing that you're going to do for me is you're going to put the ions down on your table of evidence just so you can get used to using your table of ions. And as time goes on, we'll be actually working out the formulas for this. So the formula should be NaI, because we should know that this 1+ charge from the sodium balances the 1- charge for the iodide. So our formula for sodium iodide should be NaI. Now, sodium is a soft metal, and I have it in the fume hood, and iodine obviously is this molecular compound. And the concept that I wanted to try and show you is that the pure atoms that we had, this iodine one and the metal that we've got in the fume hood, when they join together, they produce a compound that looks completely different from the constituent elements that we actually started off with. And here's another example to actually show this to you. So we've got magnesium chloride. So this is our piece of magnesium down here. And of course our chlorine gas is this. So it's almost like we're putting these two substances together to form this magnesium chloride. Has it got any similarities between the constituent elements? I would say not. Okay, so let's just talk about how we would go through and work out our formula for this one. Magnesium would have a value of, if you look on your tables, if you can't remember, of 2+, and chlorine has its ion charge is 1-, okay? So if we were working out the formula, we would drop and swap these across. So our formula should actually be MgCl2, okay? Now if this is a little bit confusing for you, don't panic about it at this stage. We will spend lots of time going through this, but I understand that some of you can remember this from previous years, and that's why I've brought it up again for you. If you want to go home and revise it, if you finish your work early, you can go back and reread some of last year's learned information about solving for ions, okay? So our final compound that I wanted to show you is, again, another one of my favorites. This is copper, and you can see that the color of this copper chloride should actually be copper 2 chloride, is really different to that of the original copper that we have here. It's a blue-green color, but that blue-green color, as you get to move through chemistry, you'll see that that's actually kind of associated with copper compounds, okay? So let's just go and work out the formula for this particular compound. Copper is actually a transition metal, which means it can actually have more than one ion, and you will see that on your chart. But this particular one is going to be 2+, okay? And our chloride has a charge of 1-. So once again, we're going to drop and swap these. So this will be CuCl2, and that's the formula for copper 2 chloride. Okay, so here I have moved to a part of our laboratory which is called the fume hood, and obviously we use this if we're performing dangerous experiments or we are producing noxious fumes that we don't want to inhale or other people to inhale. There's a switch on the side that we put on to turn it on, and it creates a bit of a vacuum to suck all the fumes up. The reason why I'm using this fume hood for these last two elements is because they're highly reactive. You will notice if you look on the periodic table that they're found in group 1. There's a very good reason for their reactivity. It's because they both have the charge of 1+, which means that there's an electron on that final shell that desperately wants to leave them, and because that electron desperately wants to leave, it makes them highly reactive. Okay, so I'm going to perform this underneath the fume hood. I'm going to show you, if you scan in and have a look at it, that we only have very small amounts in the laboratory because they are reactive, and they're actually stored in oil. Okay, the reason why they're stored in oil is because if we didn't put them in oil, they would react with the oxygen, and they would react with water, and that could be dangerous in our backroom, so we don't want that to happen. So what I'm going to do is I'm going to start with potassium first, and you can see that it is a soft greyish metal. I'm not going to use that whole piece, I'm just going to use a little bit. And the really cool and interesting thing about it is that you can cut it with a knife because it's soft, okay? So I'm just going to use a very small amount. We've stuck the fume hood on because we don't want to breathe in those fumes. The rest of it I'm going to pop back in. I'm going to put the lid back on. And then what I'm going to do is I'm going to place it into this piece of water, and we're going to observe what happens. And I'm going to pop the fume hood down, okay? So what we'll do is, before we do this, we'll remove any other bits and pieces for it to react with. And you're going to write your observations, okay? 1, 2, 3, go. Okay, so we're doing this behind a safety piece of glass, okay? And you can see even that small amount is highly reactive, and you can see that it's still fizzing. Now the really interesting thing about this, characteristics about these metals, is that when they are placed in water, they actually form a basic solution. They form a hydroxide, okay, and that's why they're often referred to as being alkali earth metals, and you can find out more about that. I'm actually going to use a chemical called phenolphthalein indicator, and this tells me whether I have a base or not. If it's turned all of my water basic, it should turn a bright pink colour. Let's see if our experiment worked. And you can see that's a positive for the fact that this water has turned basic. Okay, so we're just going to pop that down to the side. Right, so we're going to try our next one, which is sodium. Once again, I'm going to put on my petri dish, stored in oil. I'm going to place a small sample onto our watch glass. I don't want to use all of it, it's really highly reactive. I'm going to pop the fume hood down to protect my face, just in case something dangerous happens. I'm going to put one sample back in my jar, and then what I'm going to do is, as soon as I place this into the water, I'm going to put the hood down to protect me and my lab technician who's filming this. And we're seeing the reaction now. Okay, so look at that characteristic colour of that flame too. That sodium colour is really characteristic, and you'll see that again when we start doing flame tests, okay? So you can just see how reactive it really is. And it's going to take a while to actually burn out. Okay. Nearly finished. Okay, so once again, we're going to use a phenolphthalein indicator to prove that this has turned our water basic, and if we were successful, it should turn pink. Okay. And yeah, you can see that's a positive test. We have managed to change it. Okay. So your role or job is, after you've watched this particular laboratory, is to fill in your table of evidence and to do your reasoning. You'll need to use your periodic table, your table of ions, and you'll need to find out a little bit more information about some of the elements and compounds that I have discussed in today's lesson.